Sweet. Happy Monday, everybody. It is December 13th, which means it is time for Advent of Code, day 13. We're doing it in Rust. Let's figure out today's problem. Apparently it's called transparent origami. Exciting name. You reach another volcanically active part of the cave. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. When you activate it, you are greeted with, "Congratulations on your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual." Apparently, the elves have never used this feature. To your surprise, you manage to find the manual. As you go to open it, page 1 falls out. It's a large sheet of transparent paper. All right, I'll bite. Transparent paper. Oh, it's a transparency. I wonder if people nowadays even know what these things are. I'm old, so when I was going to school, there were plenty of these things. I think all the way through high school, I want to say. I'm not sure if my college professors or TAs ever used this, but this is definitely a familiar piece of technology to me. I think everybody uses probably PowerPoint nowadays. Or just the plain old whiteboard. Okay, at any rate, the transparent paper is marked with random dots and includes instructions on how to fold it up. Your puzzle input, for example, is a bunch of coordinates. The first section is a list of dots on the transparent paper. 0, 0 represents the top left coordinate. The first value, x, increases to the right. The second value, y, increases downwards. So the coordinate 3, 0 is to the right of 0, 0, and the coordinate 0, 7 is below 0, 0. Okay, so this coordinate system where y kind of increases downwards is, I think, a familiar one to us because earlier problems were like this. And I think, as I mentioned before, I think most classic video game consoles, I think before the 3D era, so like an NES or a Game Boy or even Nintendo DS, they all use coordinate systems that were like this. So not too exotic. So the coordinate 3, okay, the coordinates in this example form the following pattern where the hash mark is, or pound sign, is a dot on the paper, and period is an empty, unmarked position. Okay. Seems pretty clear. Then there's a list of fold instructions. Each instruction indicates a line on the transparent paper and wants you to fold the paper up for horizontal, y equals ... lines, or left. In this example, the first fold instruction is fold along y equals 7, which designates the line formed by all of the positions where y is equal to 7, marked here with a hyphen. Because this is a horizontal line, fold the bottom half up. Some of the dots might end up overlapping after the fold is complete, but the dots will never appear exactly on a fold line. Okay, this was going to be my question about the problem, is like, what happens if there are dots on the fold line? The result of doing this fold looks like this. Okay, now only 17 dots are visible. Notice, for example, the 2 dots in the bottom left corner before the transparent paper is folded. After the fold is complete, the dots appear in the top left corner at 0, 0, and 0, 1. Because the paper is transparent, the dot just below them in the result remains visible, as it can be seen through the transparent paper. Also notice that some of the dots can end up overlapping. In this case, the dots merge together and become a single dot. The second fold instruction is fold along x equals 5, which indicates this line. Okay. Because this is a vertical line, fold left. The instructions made a square. The transparent paper is pretty big, so for now, focus on just completing the first fold. After the first fold in the example above, 17 dots are visible. Dots that end up overlapping after the fold is completed count as a single dot. How many dots are visible after completing just the first fold instruction on your transparent paper? Get your puzzle input. Okay. I'm guessing that the second part of this problem will actually be to do both folds, and then to actually print everything out and read a message or something like that. I bet one good way of doing this problem would actually be just to like literally print this on I guess it's hard to get a transparent piece of paper, but like print it on that and then just do the folding and you wouldn't have to write the program. And I say that because if this problem is gonna have, and again, I'm guessing what part 2 is gonna do, but if it's small enough that it can basically be read on our screen, that means it's small enough probably to be fit on something that you could print out and actually do physically. So this is fun. I imagine this problem we're gonna run into a lot of off by 1 errors. That's gonna be my prediction for this morning. Just because what we're really trying to do is sort of translate a bunch of these points on a grid to other locations, and we just have to make sure that we get our arithmetic correct. So the puzzle input is a bunch of coordinates, but I think at the bottom it has the folding instructions as well. Yeah. Okay, parsing this is going to be annoying, I think. But you know what? Writing the parsing is, I think, part of the joy of doing Advent of Code. So I'm going to, for the sake of the exercise, I mean, I could basically copy and paste this into two different strings and parse them separately, but I think I'm going to try to do this the, not the honest way, but maybe let's just say I'll try to do it the hard way. The reason why I even call this hard is it's just we have 2 different phases of the parsing. The first phase is everything, all these points on a grid. And then there's a new line, and then we have to switch to a different mode, basically. So I'm going to actually collect my lines in an iterator like this. And we're going to grab the lines. I think I'm going to have to actually put the input into a separate variable because lines is going to be a Rust iterator over basically a string of basically a string, right? And unless I assign that string to another variable that remains in scope inside the main function, the iterator is not going to be able to know what to point at. So let's store the input here. And then we'll grab an iterator that references that input, and now we can iterate over it. So I'm just going to loop over the input, and I'm going to call the line lines.next. And our exit condition is if the line, and I'm actually going to do an unwrap here because we know we're not going to hit the end of the input during this first phase. So this first phase, phase 1, read in coordinates, right? And if we get an empty string, or let's say line.length is equal to 0, then we're going to break out of this loop. This is our exit condition, okay? And then we're going to go down to phase 2, which is read fold instructions. But for now, we just want to actually accumulate the coordinates. And the coordinates, I'm guessing this is going to be easiest if we actually just make a straight up grid. Right, and do we know how big this grid is going to be? It looks like we're seeing numbers that are up to like 1,000 or 1,300. I see 1,299 in there, 1,310. So if I just made this like a 1,500 by 1,500 grid, it's going to be a lot of memory, but whatever. This is just going to be the easiest way of doing it, right? So let's make a 2-dimensional grid here. So let mute grid equal to, and let's call this a vector of it's really just Booleans, right? Is it on or is it off? And then I'm actually going to let size, I'm going to make this a square. I'm going to call this 1,500. And we're going to say that this equals a vector of false size. I don't know if I can do this. No, it works. I wasn't sure if I could basically do this sort of vector macro expression with a variable. I wasn't sure if they're going to force me to do a constant of some kind. But maybe this is a constant expression, right? Because I've hard-coded it in there. Okay, so now what we're going to do is we're going to split this line, let tokens, equal to this line, and we're going to split it into separate characters by the comma character. And then we're going to read the variables in one by one. Do I want to use row and column or X and Y? Why don't I use X and Y? Because that's just what, that's just the language of the problem. I can stick to that. And I believe it's X before Y. First value is X. Yes. Okay. Tokes.next.unwrap.parse. And what we're saying is this is a U size. It is an index into a grid. Okay, it looks like splitting the line gives me characters. How about if I split it as using a string? What does that do? Okay, that's what I wanted. Y will be similar, and then what we can do is we can say that grid of Y and then X, because we're going to do rows and then columns. Hopefully that's not too confusing. Maybe it might be easier if I call it row and col. I know I wanted to stick to the language of the problem, but flipping X and Y sometimes can be a little bit confusing. So for now, maybe I'll just do it like this. Okay, so far so good. That will basically produce our grid. And now we need to read the fold instructions. And our folds are going to be, I think, a combination of an axis and a number, right? X and a number. So I think I might just represent the fold as a tuple. You know what? This is Rust. Why don't we just make an enum of it? An X fold with a U size and a Y fold with a U size. And as with all structs and enums I like to derive a debug, clone and copy, because these are small. These are essentially just like, what? An indicator of whether it's an X or a Y, which is essentially just like probably an int32 or an int64 and then an int32. So this isn't too huge, so we're not afraid of making this a copyable value. And then we'll create a vector of these fold enum values when we read in the fold instructions. Before we dive into that, I'm noticing that this is still complaining here. I just want to make sure that I've gotten everything. Next is an option, unwrap. What exactly is it complaining about? Let's read the full message. Expected U size. Okay, so I just need another layer of unwraps to make sure that the parsing is working correctly. And then tokes needs to be mutable, right? Because this is an iterator, and we need to mutate the iterator when we advance. When we advance it. Okay, and then I think we'll do something similar. Or to be honest, I think we can just like do a for loop now over the remainder of the lines iterator. For line in lines, we are reading in along x equals blah, 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 right? So what's the best way of doing this? I wish I could just use scanf, but there's no scanf in Rust except via crate, and I don't want to use the crate. So I guess what we can do is we could split along the entire string fold along and then get, or we could just strip the prefix. I think there might be a strip prefix in Rust. Rust string strip prefix. Oh, they're just doing a length of this thing dot dot. Oh, there is a strip prefix. Well, it's in standard path. It might be in a version of Rust that is not available to me yet. Let's see what the language services tell me. If I do line.strip, oh, it's got strip prefix. There we go. I think potentially strip prefix might be overkill, because what strip prefix probably does is it checks to see if the string actually has that prefix, and if it doesn't, it's not going to modify it. Whereas in this case, I know for a fact that's going to have that prefix, so I could technically just like slice by the length of this string, which is maybe what I'll do. I'm going to actually replace the variable line with line. Can I do fold along space dot length dot dot? So essentially, I'm just like removing the first part of it. It doesn't know the length at compile time. Has to be statically known. Consider borrowing here. All right, I'll borrow. Now we can split that. By an equal sign, right? And then we will check to see if the first string is X or if it's Y, and then we'll parse the second one, right? What do we call it? Let axis equals tokes dot next dot unwrap. Let num or val, let's just do num, equals tokes dot next dot unwrap dot parse dot unwrap, and we'll call this a usize, right? Oh, tokes needs to be mutable, right? Because this is an iterator that I'm modifying. And then what I'm going to do is I'm going to match axis. And if it's an X, we are going to have a fold X of num. If it's Y, we're going to do a fold Y of num. And otherwise, we are going to panic why don't I call this line fold along? So the full line is this. And then the specification is this other token here. So whatever, I think this is sufficient. We'll probably never hit this line of code, assuming that we have well-formed input. And then what we're actually going to do with this is we're going to push it onto the end of a vector. Is that right? I could technically do a map for this, but given the size of this thing, I don't mind having a for loop here. Well, let's try it. Let's try it. Then it doesn't have to be mutable, which I like. Lines.map of line. And then we need to collect at the end. Okay, we've got our folds. Okay, so let's actually just print everything out. Just let's make sure that we've done it correctly. So we'll go ahead and debug our grid. Pretty sure that's going to be fine. Debug our folds. And now we run. Okay, so the grid is going to be massive. 1500 by 1500. That's going to be like a million things. So I don't really want to, maybe I don't want to print this out for the time being. Let's just trust that I parsed it correctly. Okay, so x 655, correct. And what's the last one? Y equals 6. Okay, I'm pretty confident that we got the parsing correct. And maybe we can just hope that this is correct. Okay? Okay, so we actually have to process a fold right now, right? Because we have to do the first fold, and it's a fold along x. I'm guessing I'm just going to write the fold along x case for the time being. And then we probably, for part 2, we'll want to write the full thing. So if we're folding along x, I would love to have a sample. Let's say we are doing, let's just make up an example. And what I'm guessing about the fold is that the fold is never going to cause the bottom edge or the extreme edge of the fold to go past the closer edge of the fold, right? And so what I mean by that is if we had a piece of paper, do I have one here that doesn't have personally identifying information on it? I guess I can just grab a piece of paper. So, got a piece of paper here, and I'm not sure how to orient this, but like, let's say I'm folding along X. That's going to be this type of fold, right? Folding on the x-axis. And I'm guessing that the folds are never going to have to go past the origin of where I currently am. So I'm guessing the most it'll go is this far, right? Okay, so if we're talking about the fold along X, this is just one row of it, but one row will generalize to all of the rows. What we are doing is however many characters we are to the right of the fold mark, we just want to take that character and move it that many characters to the left of the fold mark. So let's actually add some indices here to make it a little bit easier to understand. And I'm just going to wrap over, and we just know that this is actually, just to be extra clear, let's put all zeros here. And the way you read these numbers is just vertically, right? So this is 0, this is 0, 1, 0, 2, and then over here we have 10, right? Okay, and so what we want to do is if we're folding this 8th column over, this is 1, 2, 3, 8 minus 5, which 5 is where the fold is 3 more than where the fold is. So what we're going to do is we actually want it to be 3 less than the fold, which is 2, right? So we do the hyphen position minus the distance, which is 3, and 5 minus 3 is 2, right? And the reason why I'm being so laborious about this is I want to make sure that I'm not off by 1. So I think I kind of understand what the analysis is here. And then this is just our data representation is just a vector of Booleans. And we're only ever going to change a false to a true, right? So when we fold, I think what's going to happen is we actually need to also, in addition to keeping track of like essentially which dots left of the fold are going to be marked because of the fold, I think we also want to keep track of how far what the limit of our what the new edge of our x-axis is, right? Because our grid is going to be like way larger than the piece of paper is going to be after the fold. And when we're processing subsequent folds, we want to make sure that we're not trying to process like we're not trying to process elements that are past that are on the in the grid data structure but aren't actually on the folded piece of paper. I am going to take a really quick break. And once I'm back from that break, we can pick it back up.
5 minutes later.
Okay, so we were just about to... We talked about sort of like the implementation of the folding algorithm. I guess algorithm is a little bit of a overstatement here because I don't think it's going to be that many steps. But let's go ahead and get started in the implementation. So one thing I think we realize is that we actually want to know the height and width. Num rows, and let's also call it num calls, num columns. So in here, we're going to use num rows, and then out here, we're going to use num calls. Now that we've parsed everything, we're going to actually process the folds. So we're going to just do the first fold which is what the problem is asking us for. So f in folds, I think we probably don't need to keep the folds around, so I think we can just move the fold as we iterate over them. We're going to break after the first one. We're just going to process the first one. And we are going to do a match on the fold type. And if it's an x, what I call this num, we're going to do something here. And if it's y, anything else, we're just saying it's not implemented yet, right? Is there a not implemented macro? Unimplemented. Perfect. That's what I was looking for. Okay, so here, what we want to do is, if it's a fold along the x-axis, we are going to start at the column so we're going to do like a for loop from num plus 1 to num calls, right? And we're going to do this for every row. So for 0 to num rows, and this is going to be the row, and this is going to be a column. Now how do we process a single... This for loop is just processing a single row. How do we process a single column when we're folding along the x-axis? Well, we're going to take the delta is basically the current column that we're on minus where we started the fold. And that's going to be a positive number, and we're going to subtract that from where we started the fold. So I guess we're just updating the grid in the current row. And we're going to say that this minus delta is equal, and we're only going to worry about this is if the column is populated. So if not grid row column, then continue, just skip it, right? Otherwise, we're going to set this equal to true. And then once we're done with that, we're going to say that the number of columns is equal to where the fold is, right? Because once we do the fold, we're going to lose a bunch of columns. And the last column in our newly shrunken piece of paper is going to be where the fold was minus 1. All right. I think I need to actually scope this in. I need to call this a fold x. Number of columns, we've never read that. That's fine. we'll get to it. Now that we've broken here, what we're actually going to do is count all of the cells in the grid that are true, right? That's what they're looking for. How many dots are visible? Let's just fold over our columns, fold over our rows, and then fold over each cell in the column. So that's the grid. We're going to do a iterator on that. We're going to fold. And our accumulator is just our number of visible that we've seen so far. And we're going to have a row coming out of this. And the result of this will be the accumulator plus whatever we accumulate inside of this row. And then so we're going to do row.iterator. Why are you having a hard time? Oh, I didn't add a comma here, that's why. That's also fold. This is the row score. And this fold can actually just be like a filter. This is a cell. And we're just gonna basically count these. And then we're gonna print the number of visible. And this is complaining probably because I needed to reference this. Yeah. All right, let's go ahead and run that. There's a couple of problems here. Yeah, that's just because I haven't done the Y folding yet. And this is because I haven't run this in a loop yet. So this is okay for now. These two warnings. 1,112. Well, I guess let's just give this a shot and see if I did it right. Okay, answer is too high. So let's just go ahead and take the sample input, shall we? The issue with the sample input is that the first fold is going to be along the y-axis, so I actually have to implement that, which is not a big deal. I think what I can do is sort of just copy the y version, the x version of this, and maybe just change up my columns and rows. So for the fold, we're actually going to start at num plus 1 to num rows, and then we're going to go across every column. Okay, that looks good. Row and then column. The delta is the row minus the number. And then the row here is going to be the num minus delta for the current column. And then num rows equals the number. And then we're not going to break here, right? Okay, so this one says after the first fold, 17 dots are visible. Let's add that break back in. And let's just see what happens when we run the sample input after the first fold. 27. Okay, so that's too many. Oh, you know what it is? I'm iterating over the entire grid, and I haven't unset the other ones here. rather than iterate over the entire grid, the whole reason why I'm keeping num rows and num calls here is so that I can do this iteration a little bit easier. So let's just do let mute count 0. And then we're going to do for row in 0 to num rows. And for call in 0 to num calls. This will just make it faster to count, basically. Not that it matters that much. And then if the grid is on at that point, we're going to add 1 to count. And I don't need these parentheses. 17. Okay, that looks correct. Let's try it with our actual input. 693. Whew, that's a relief. Great. Finish folding the transparent paper according to the instructions. The manual says the code is always 8 capital letters. What code do you use to activate the infrared thermal imaging camera system? Okay, so we actually have to do the folds, and then we actually have to print it out, which is going to be fun. So we actually can do all the folds. We've written our fold code here, and I think we're confident that we got X and Y correct because our sample input used Y, and our actual input used X. So hopefully, if these are both correct, then using them in sequence is going to be correct. And so now we just have to print it out, right? So what's a good way of doing that? I guess we can collect every row into a string and then just print each row, right? So we could do for row in rows, or in grid. Let's println row dot iter.collect as a string. Actually, these are Booleans, right? So we actually need to translate this into something. So what we'll do is we'll do let s equal row.map, .iter.map. And here, this is just going to be on or off, right? And if it's on, then we will do a hash sign. Otherwise, we will do a period. And I believe we can, I guess we can do characters instead. This is maybe makes a little bit more sense under the hood. And we can collect these into a string. And we need to dereference this Boolean, and then we can print the string. Oh, I need an actual concrete literal format string here. Println's not going to bite otherwise. Okay, and then it has one more complaint. Count is never used. That's right, we're not really counting anymore for this second part. Oh, I realized what I didn't do was commit this code to Git, so I'm overwriting my original solution. So I'm going to go ahead and just like copy this and just paste this into a scratch buffer, and then let's do a bunch of undos here. We'll go back in time. Luckily, the undo buffer is nice and long. Let's make sure that runs still. 95. Oh, it's because I got rid of the break there, so this should be 693. Great. And let's go ahead and make like a full copy of that. Stick it in its own directory. compile its own directory. Okay, that works. Just going to reload VS Code real quick, just so it recognizes the new directory, and we'll be on our way. This is our scratch buffer. And I believe we just slapped that down here. We get rid of the count because we don't need that anymore. Make sure we're not breaking after the first one. And I think we are on our way. Now let's run it. Gosh. Okay, I did it again. What I'm not doing is limiting the grid by the number of rows and number of columns. Okay, that's totally fine. So what we'll do instead, we're still not learning the lessons from the previous, from what we did earlier. What we can do here is I'll just println nothing after every row. If it's on, we'll just print it we'll print a hash symbol. Otherwise, we'll print a period. Could be space as well. And we're not trying to accumulate a count anymore. So let's try that again. Okay, so these do look like capital letters. It looks like a U, C, L, Z, R, A, Z, U. I was hoping it would spell out a word, but maybe something random is a little bit better for a programming competition. Is that 8 characters? 8 capital letters. Okay. Sweet. Okay. So I think other than just making sure that I was using the limits that I already anticipated in printing out the output, this one was relatively straightforward. Okie doke. Well, that's day 13 of Advent of Code 2021 in Rust. I will talk to you guys probably tomorrow at a similar time. Bye.